Hi everyone, welcome back to my channel. Today is day 2 of DSA bootcamp, and today morning I had posted one video on process 3 sum, which is present in GFC portal, and I have explained everything. uh, Languages supported, and these are the dry run examples, and everything has been explained. Now I will be explaining the lead code problem, and this is the problem. Average waiting time. There is a restaurant with a single chef, and you are given a customers array where customers is in two-dimensional array, and customer I indicates that first part of an array, which consists of two things. One will be the arrival time of the customer, and Ti indicates that time taken to complete the order, to make an order delivery. Okay, and has it mentioned the same thing what I discussed earlier? And when a customer arrives, he gives the chef his order, and the chef starts preparing its own. Once he is in idle, whenever the chef is idle, then only he will pick the order and he will start preparing for that, and the customer waits till the chef finishes the preparing his order, and chef does not prepare orders for more than one customer at a time. He is not a multitasker. He will do one order at a time. He'll prepare that, and the chef prepares the food for the customer in order they were given the input. Whatever the input area is given, he will prepare accordingly. And we have to find the average waiting time for all the customers, and the solution should be accepted for 10 power minus 5 from the actual one. That's 10 power 5 only, within the range only. The solution is accepted. We need to use modulo to avoid overflow, whatever the constraints have been given. And this is a question given to you, and the entire expectation is to understand the question, ask the follow-up questions on top of it, and then you start giving your approach and intuition. And once the interviewer okay with that your intuition, then you can start coding up. And this is the I'm going with an sample test case, and this two-dimensional array given, and the first customer is the first array indicates that first customer, and he arrived at the point of time one, and his order will take 2 minutes, like 2 seconds. This is the order completion time, this is the customer arrival time. So similarly followed by other elements. Okay, and the first customer arrives at a time of one, and the chef takes his order and start preparing it immediately at the time of one. Whenever he arrived at time one, initially chef will be idle at 0 to 1, and he will start doing that, and it finish at the time of 3, because it takes an order of 2. So you can see that 3, and I will be teaching the here itself, so that you will get better idea. Yeah, and the first customer, right? It will take 3 minus 1 equal to 2, of 2 of waiting time for the current customer, and the second customer arrives at a time of 2, and the chef takes his order and start preparing at the time of 3 and finish at the time of 8, because the order completion of this customer 2 is 5. So 3 plus 5 equals 8, and 8 minus 2, 2 is the initial customer started arrived at. So 2 8 minus 2 equal to 6. 6 is nothing but waiting period for the customer 2. And the third customer arrives at 4, and he takes an order and start preparing at the time of 8. Whenever he's completed his previous order, he will pick up the next order and he will process the other one. 8 plus 3 is equal to 11, as you can see. And the third customer waiting time will be the 11 minus whatever he arrived at starting time. So 7. 7 seconds he will be waiting the third customer. So average waiting time will be the summation of all the waiting times of individual customers and dividing by number of customers. You will get in 5. So we are writing as a double format and within the range of 10 power minus 5. That's what the expectation. Similar thing for the second test case. So approach is kind of an simulation approach we should follow. It's kind of a creative algorithm. So here the given the customer array, and we have to take two pointers. Uh, Next ideal time indicates that the chef will be available ideal after this next ideal time. He will be available to take an order. And next waiting time indicates that mm, summation of current sum cumulative sum of the particular customer waiting times, so that we can divide it. And here go. Chef is an ideal from 0 to 4 because the order starts from customer starting at 5. Here, the customer's initial starting point is 5 seconds. So at 0 to 4, he will be sleeping, the chef, and after that he will start picking the first customer arrived at 5. He will start doing preparing his order, and with help of loop we can traverse the entire array and take the max out of arrival time, initial time of the current customer, and the next ideal time the chef is available. This is the maximum so that we can pick, and we can take the preparation time is nothing but the current order, particular order, the second index of every element. That is the preparation time for the current order, and we can add up to get the next available of the chefs to take an order, another order. So waiting time, how we can calculate with the help of next idle time, total time it takes minus the initial the customer arrived at. So we'll get an waiting time. This would be cumulative, and you can see that the pseudocode, the algorithm, it's kind of a simple. We have to take two pointers and we have to traverse to entire array length and each element. Next ideal time indicates for the chef is given by the time to deliver to the current customer orders, his order. Okay, taking the max of the arrived time, this zero index, and next ideal time will be the chef available for the taking the next order. And customer one indicates that time to prepare his order, and then the waiting time, right? The waiting time indicates that the current customer, he will be waiting till delivery time and the arrival time. It's nothing but he arrived and he is sitting in the restaurant and waiting for his order. That's called a waiting time, and that can be cumulative because this is cumulative sum, so that we can divide at the end. No need to again overloop and storing nothing else. To avoid that, we are doing the accumulation sum here, and we are subtracting with the initial, the current customer initial time with the next available once the order is placed, the delivery time. So he delivered the current order minus the initial time he arrived, so that the current customer waiting time will be calculated. Similarly, we can accumulate. Uh, we can add up all the iterations, all the elements, and then we can divide by customer length. We will get an average waiting time, and time complexity will be the linear as we are traversing entire loop and checking everything. We are not storing any additional. We are storing two variables which will be storing in stack space under our main memory. Yeah, coming to dry run, initial points as we discussed, and the first customer arrived as you can see, and we are taking the max of it, who's arrived, and adding the his preparation order time, and taking the his waiting time and accumulating every time we are adding up here. And once we get it, as you can see, we will getting all the waiting times of three customers, and divided by 3 is equal to 5. Similar for the second dry run of the example, taking the max and taking the next idle time and next waiting time for each customers, and summing up, you can see the 13 divided 4 is equal to 3.5. That is what expected matching, and the time complexity, everything will be explained. A simple iteration, it's kind of a constructive algorithm how we can prepare. So yeah, see, as you can see, he will be idle for some time in between, and he will pick once he got a customer, then he will start preparing his order. And at the end, we are dividing by four. Number of customers arrived and number of orders has been taken and has been completed. That's all. Yeah.